Hi everyone, I'm Sneha S. from Sri Venkateshwara College of Engineering, Department of Cybersecurity, studying in third sem. Today I'll be dealing with a topic called Interprocess Communication, in which reader-writer process. It is from operating systems. So let us begin. Contents we are going to study today are interprocess communication, reader-writer process, APIs, MK4 open, read, write, and close. So let us begin. Interprocess communication is a mechanism that allows different processes to communicate with each other and share data in an operating system. It enables processes to exchange information, synchronize their activities, and coordinate their actions. Which means when there are different processes which are somehow related to each other and we want to communicate between them, then we use interprocess communication. This can be done by several methods, out of which two are listed below. The first one is pipe. Pipe is a communication channel that allows one-way communication between two related processes. One process writes to the pipe and the other process reads from it. The second one is message queues. Message queues allow processes to send messages to each other. Messages are stored in a queue and can be read by the receiving process in the order where they are sent. Using CPU scheduling algorithms or other ways, these messages can be read. Now let us see into reader and writer process in the process communication. The reader and writer processes are two separate processes that communicate with each other by sending and receiving data. The first one is reader process. The reader process is responsible for reading data from a shared resource or receiving data sent by the writer process. It waits for the writer process to send data, then retrieves and processes that data. The reader process typically listens for incoming data and performs operation based on the received information. So whenever a reader process has to read data, it had the two possible ways. First, it can access any shared memory resource and access data from it, or else it has to wait for the writer process so that the writer process writes the data and send it to the reader process. Now let us see what is writer process. On the other hand, writer process is responsible for writing data to a shared resource or sending data to the reader process. It generates or collects the data that needs to be communicated and then sends it to the reader process and stores it in a shared location for the reader process to access. So now that the reader process has to access the resource that is shared by the writer process, the writer process will be sharing data to the shared location from where the reader process can access it, and it can directly send the data to the reader process. In this reader and writer process, we'll be using header files. First, the most important one, and this is unisted .h, which I'll be saying later. The first one is stdio.h. This provides functions like printing and scanning. The second one is fcntl. It provides functions and constants for file control, which means open and close. Next, sys/stat.h. It contains structures and functions for file status and attributes, such as stat and chmod. Sys/types.h. This header file defines the various data types used in system calls. PID underscore slash, which is parent ID, process ID type, and the second one is size/t, which is size type. And unistd.h is the most important one because it provides access to various operating system services, including read, write, and close. So to demonstrate interprocess communication using APIs such as MK4, read, close, write, and open, let us consider a scenario where a reader process and a writer process are communicating each other with the pipe. So this pipe in here is named NK4. So we'll include the header files, that is stdio, fcntl, and sys/stat.h, sys/types.h. Now let us create a pipe named FIFO, MK4, and the location where it is. Now we've created this pipe. Now let us see a reader process in order to open this pipe using the system call or a function call open. Again, we are in the header file, we are including the header files which are necessary for executing this program. Now let us consider file directory FT and a buffer of size 100. Now let us open the pipe. So open MK4 and here we are reading, um, sorry, we have to read the data from the pipe. So we are using the system called O underscore RD only, which means read only. Now in the next step, it reads the data from the buffer, which is of some size, whatever size it is taken, and will display this particular message by printf and close the pipe. Now in the writer process, we have to write the message. So in the char message, we are writing hello from the writer process. Now we are opening the pipe using the system called open and also the system called o underscore wr only, which means write only. And now we are writing the message, which is which is in a string. It has some length. And now after we are writing the process, we'll close the pipe. So now let us see the real world applications of interprocess communication. Interprocess communication is used in client-server architectures, which means whenever clients and servers have to interact with each other over a network, then we use IPC mechanism. Next, they're used for process management, memory sharing, and device communication. Distributed systems rely on IPC for inter-node communication and coordination. Next, we'll see the advantages of interprocess communication. IPC allows processes to collaborate and coordinate their activities, leading to more efficient use of system resources. It enables parallel processing and multitasking, improving overall system performance. Next, it facilitates modularity and code reusability by allowing processes to interact independently. The whole concept of interprocess communication is that firstly, they'll communicate with each other. And next, there'll be parallel processing and multitasking will be happening because they'll be using the shared resource memory. And they can, in this way, we can use the code again and again. And also, it allows the processes to interact independently and individually. Conclusion. So in IPC is a fundamental concept in operating systems and concurrent programming, enabling communication and coordination between separate processes. So here are some takeaways in interprocess communication. The first one is IPC mechanism. So IPC mechanism means whenever processes have to communicate with each other, which are related, then we'll be using mechanisms like pipes, message queues, shared memory, sockets, and signals. Each mechanism has its strengths and weaknesses, making them suitable for different scenarios and requirements. Synchronization. In concurrent environments where multiple processes access shared resources, synchronization mechanism uses semaphores. Semaphores is a integer value, non-integer value, which can coordinate multiple processes. Mutex is similar to semaphore, and monitors are essential to prevent race conditions, maintain data integrity, and ensure correct program behavior. Coordination. IPC facilitates coordination between processes by allowing them to exchange data, signals, and messages. This coordination is crucial for implementing complex systems where multiple processes need to work together towards a common goal. So by using IPC mechanism, synchronization, and coordination, the whole process of interprocess communication is possible. That's all, guys, for today. Thank you for watching. Please like and subscribe to my channel.